So hello everyone, I'm Zheya, a PhD student of the DAL University. So my topic is related to like carbon storage assessment in biosolid amendment soil using mid-infrared spectroscopy technologies. So first we'll start some introduction related to the soil carbons. And like a soil organic matter is a major sinks of the soil carbons. It usually contain like 58% of organic carbons. So the carbons really benefit to the soil, can enhance like fertility, microbial biodiversity, and some like physical properties. And another part is biosolid, which is a stabilized organic solid derived from like wastewater treatment plant process. They also contain a large amount of the nutrients. So which usually used as a soil improver and like organic fertilizer to the agricultural soil to enhance like a crop yield and the nutrients. So they contain like a valuable source of organic matters, so it can promote like the soil or increase the soil organic carbons and also like promote the sequestration in the soil carbon storage pools. So as we know, like the soil analyzed for each parameters have their own individual analysis, so which is may take a labor intensive and time consuming. So like the med infrared spectroscopy is a technology that investigates for like a rapid non-destructive analysis of the soil. So it can be applied to predict the number of the importance of the soil property. So the intensive of the fundamental molecular frequency related to the soil compounds or components will occur in the MYR range between wavelength like 2500 and 25,000 nanometers. And like FTIR, which right now is a preferred MIR spectroscopy technique in last 20 years because of it can give us quantitative information fastly and precisely. So in like FTIR spectroscopies, here is interval range wave, which is synthetic from like two beams separated by a beam splitter. So the detected waveforms is Fourier transformed, and the spectrums were obtained by the separate each of the wave numbers. So in the FTIR spectrum in MIR range, so they can absorb the radiation by soil samples, can give a overall chemical profile in the soil. Here is an example show you can get a nature and a portion of the soil organic matter and the mineral compounds. The peak will indicate like the function, each function group of the soil parameters here. And so the objective of this study is to want to correlate the MIR spectra from the soil samples they can receive in the biosolid application site. We also request some sample from other provinces in the Canada with some in order to increase the sample size to develop the model to predict how much like biosolid carbon will distribute or dynamic in the soil. So the method for the preliminary testing right now, we're sampling from the last year in the two biosolid amendment site in the Nova Scotia, Canada, and the air dry the soil and ground them for the further analysis used in FTIR instruments. And each sample will be analyzed for conventional analysis for the total and the organic carbon use like combustion method. And we also want to determine like a water extractable carbon, which is rapidly arrival carbon to, and also a sensitive indicator for the labile carbon pools. It is really easy to available for the microbial processing in the soil, and also this a parameter that decreases during the decomposition process, which can relate to the process of the carbon stabilization in the soils. So because of like biosolid contain a large amount of organic carbon, the really labile pool is quite easy decomposing soil. That part will be indicated over there. And for the MYR spectral part, we will you play the soil samples 3 replicates in the microplate and use the FTI instruments to determine to scanning and get the spectral acquisitions. So here is a sample I just did the last 2 weeks before to see the actual real spectral look like is here. And after we do the whole sample scanning and the acquisition, we start to do the modeling analysis. So all sample will be separated by 70% for the training set and 30% for the testing set to use to testing the accuracy of the model predictions. And in the spectral modeling size, we prefer before the model training, we do like a pre-processing to reduce the noise and enhancing some like important properties. And we use a partial linear square regression to do the model trainings, which can maximize the covariance between the prediction variable and the response variable assessed to in order to assess the greenness of fit of the prediction model. And in order to test the performance, we plan to use see how much accuracy of that. So we use the coefficient of the determinations, root mean square error, and the residual predicted deviations. Like the lower root mean square error and the higher root R square and the higher RPD will get a better model performance. So right now, the study is at the spectral acquisition stage. So I didn't have the actual result or outcome of them. So we just have the expecting outcome with the example, hoping the exam parameter will be sensitive towards the chemical composition of a biosolid, so they can be used as an indicator in the biosolids carbon in soils. And just hoping the prediction model can be the feasible approach to predict the examining carbon pool in like biosolid amendment soil, in biosolid amending soil. Yeah. Thank you. That's everything.
Great. Thank you very much.